So looking at number 10, we know f prime. I mean, it's just a picture, but we know some information about f prime, and we're looking for f. So if I want to get from f prime to f, what do we need to do? Integrate, or antiderivative. So I need to antiderivative f prime, because I know that will get me back to f. Now, this isn't complete yet because I've got specific values that I'm thinking about. So what should my limits of f prime be? I would say that opposite of what you said, but negative 4 to 4, which means it will be f of 4 minus f of negative 4. Supposed to be working this on a separate sheet of paper, so here we go. Here's my separate sheet of paper. F of 4 we know. This integral we can find out because that integral is also the area. Find f of negative 4. So, let's see, if I do some algebra, f of negative 4 is f of 4 minus that integral. That was just algebra, moving stuff around to put it in the right spot. F of 4 they told us was 7. That integral is the area from negative 4 to 4, which would be 1/2 pi r squared and goodness, for all we care, we can safe stop that and be fine. Other questions? I should probably do some of those word problems. Those word problems are popular test questions, both mine and the AP. So 7 and 8 especially. Yes. You got a preference on? They're pretty similar. Both of them. All right. Let's do 8 slowly, and then I'll do 7 quickly, because the answer to 7 is posted online. So if you need more help on 7, you can find it there. Number 8. A particle moves along a line so that any time t greater than 0, its velocity is given by t over 1 plus t squared. S of 0 equals 5. Determine the position of the particle at time 3. So find S of 3. Well, do you remember that velocity is the derivative of the position? So if I have velocity and I want to get to position, what should I do to velocity? Take the antiderivative of it. All right, so this is, earlier we were looking at f prime, f double prime, and talking about, going up and down the ladder for that. It's sort of the same thing here, s, v, and a. So if we're at v and we want to get to s, that's an integration. So let's integrate v. I'll plug it in a minute. And that should give us s. And then the x values, or I guess t values in this case, 0 to 3. So s of 3 minus s of 0. S of 0 is 5, so s of 3 is what we're looking for. So if I move s of 0 over, we know s of 0 is 5. That integral, I don't know, plus. But I've got a calculator. batteries that work. Not that one. So math 9. Some people just remember math and scroll till they find it. Other people just remember that it's math 9 is what they want. 0 to 3. Get fancy and put a fraction bar in there if you like. And you can put it in terms of t, but the x variable is easier to use, so I'm just going to put it in terms of x. That's the same thing. So the antiderivative from 0 to 3, x over 1 plus x squared dx. Let the calculator do the work. Not the only, but one of the problems that some people have is they'll write that as the answer. But that's not the answer, because I need to add that to 5. 6.151. So if they give you a derivative, they give you a rate, and you want the underivative, well then take the underivative. Use an antiderivative. And sometimes that means use the calculator if it's ugly. Sometimes it means use a picture if they give you a picture with area. And sometimes it means doing it by hand if you don't have a calculator. Number 7. Let F represent a bacterial population in which there's 4 million at time 0. So that means F of 0 equals 4 million. After t hours, the population is growing at a rate of 2 to the t. So that's rate. Rate is a derivative. So another way to say that is F prime is equal to 2 to the t. Rate means derivative. Find the total increase in the bacteria population during the first 3 hours and find the population at t equals 3. So if I integrate f prime, that will tell me something about f. Oh, this problem is worded a little bit weird because it asks for 2 things: the total increase and how much after 3 hours. Well, if I integrate from 0 to 3, that will be the total increase. That's how much we've added. So that's the first question, and then we'll just add 4 million to that to get the new population. F of 0 plus integral 0 to 3 would give us F of 3. Integrate a rate to get back to the original. Antiderivative the derivative to get back to the original. Math 9, 0 to 3, 2 to the x dx, 10.099. Okay, so that's the total increase. So that's part of the answer. But we started with 4. So if we add 4 to that, 14.099, that's the population after 3 hours. So it sort of asked for, it asked for 2 things in that problem. Okay, I think that's enough for now. Again, the odds, well, all the answers are on the back. You can check your answers. We got 7 right. That feels good. And the odd answers with work shown are posted in Schoology. So you can find more help there if you need it.